up, guys? Welcome back. Hope you guys are doing well. Happy Friday. All right, so geometry, you guys are starting a new chapter, chapter 11, so I'll put the link to the notes in Classroom. Make sure you download it, print it out if you can, and fill it out. Algebra 2, you guys are going to continue on in chapter 4, so make sure you guys are taking good notes. Now, both classes, you guys have a quiz next week, so if you have any questions about preparation or what to expect, make sure you email me, and then if you need extra help, we can do a video chat if you want. Yeah, that's it from me. Enjoy the lecture. See ya. Okay, so we're starting a new chapter, chapter 11, and this chapter is kind of cool because we're looking at solid geometry. So previously, in chapter 10, we were looking at area, how to calculate the area of a different shape. Well, this chapter is all about three-dimensional shapes. So we're looking at solid geometry, which is three-dimensional shapes. So instead of calculating the area of a shape, we're going to be looking at the volume of a shape. So the volume is just how much space, three-dimensional space, a shape or a figure takes up. So we're going to say that a three-dimensional figures, or solids, can be made up of flat or curved surfaces. Each flat surface is called a face, and an edge is a segment that is the intersection of two faces. Now, a vertex is the point that the intersection of three or more faces where they all come together. So, in your notes, we're going to be looking at this page here. And we're just going to be going through all those different definitions and just looking at the different parts of our three-dimensional shapes. So first, let's look at a polyhedron. Now, what is a polyhedron? Now, poly means many, and then hedron means faces. So we're looking at a shape with many faces. Now, for a polyhedron to be a polyhedron, what we need is a closed three-dimensional solid that's bounded by polygonal faces. So that's the definition for a polyhedron. It's just a closed three-dimensional solid bounded by polygonal faces, or you could say polygonal faces. Now, closed, what does closed mean? It means that it can't be open. Everything has to be shut. I can't have a shape that is like, let's say I had a shape like this, and this side, this face here is missing. That wouldn't be a closed, it's not a great sketch, but that would not be a closed figure. So we need to look at completely closed off figures. Now there are different parts that we're looking at. Back over here, we have a face, we have an edge, and a vertex. So let's look at each of those. So the face is this portion here. That would be a face. So the face is just the side of your solid. Now the edge, we have a lot of edges in this shape here, and the edge is just where two faces or three faces come together. So that would be an edge. That would be an edge. That would be an edge. Let me do this a different color. So we have an edge right here. We have an edge right here. an edge right there. So the edges is just what it sounds like. It's the edge of the solid. That's my edge. Now the last one we have is a vertex or vertice. So your vertex is where it's the pointy parts on your shape. So that would be a vertex. So the vertex is where you have, it's the corners of your shape basically. It's where everything comes together at a specific point. The edge is a segment, it's made by a segment. So for the edge, if I want to name this edge, let's say this edge right here, that edge would be segment AD. If I wanted to, so these are my names. If I wanted to name this vertex point right here, that would just be point C, because your vertex is just a point. Now to name the face, the way that we're going to name the face is just notice that, let me erase some of this. Let's say I wanted to name that face right there. Well, to name this face, notice that I have a rectangle right here. So all I'd say is that that face is rectangle. I'm going to go B, C, F, E. I just pick a vertex and just work my way around in order. Don't cross over. Don't make the mistake of crossing over. So you wouldn't want to go like this. You wouldn't want to go B to C over to E to F. That's wrong. Don't do that. Make sure you work your way around the shape, naming the face. Now what if I wanted to name, because this is also a face here, this is a special kind of face because this is actually the base. So the base there, if I wanted to name that base, well, what kind of shape do I have? I have a triangle. So I can just draw a little triangle, and that'd be triangle A, B, C. So the name of that base would be triangle ABC. So we have our faces here. I have one face, two face, and I'd also have a face on the back side. And then I have two bases. I have a base here on top and a base here on the bottom. That'd be base DEF. So three faces, one, two, on the back side three, two bases, top and bottom. And then my edges, I have an edge here, that's edge AB. I have BE, DE, EF, CF, DE, I'm sorry, DF, that's a F, DF back there, AD, AC, BC. So for the edges, you just go through and name all the different edges that you see. So I'd have 1, 2, 3, 4, 5, 6, 7, 8, 9 different edges. Now for the vertices, if I want to name all the vertices, I have one here, 2, 3, 4, 5, 6 different vertices. That's just point A, point B, point C, point D, point E, point F. So you will have to do that on the quiz. You have to name the edges, the faces, the bases, and all the different vertices. So that's something you will have to do on the quiz. Now, let's go ahead and look at our prism. Now, a prism is formed by two congruent parallel faces, which we actually call bases, and the lateral faces are parallelograms. So that's the definition for our prism. We have two congruent parallel faces called bases. So that's the top up here and the bottom down here. Those are the same shape, everything's the same, and they're also parallel to each other. So those are my bases. Notice that this would also be, going back up here, those are congruent and parallel. Now my lateral faces, lateral just basically means going around the side. So these going around the side here, those are my lateral faces. So we're going to be using the term lateral face a lot, and it means the sides going around the shape. So my lateral faces are parallelograms. So that's what makes a prism. Now let's go ahead and look at a pyramid. What makes a pyramid a pyramid? Well, with a pyramid, we have one base, and we have triangular, lateral faces that intersect at a common vertex. So a pyramid, we have one specific base right here on the bottom. That's my base. I could rotate that however I want, but the base is the one shape there. Now the lateral faces, the sides going around the faces going around the shape, those are triangles. So if you have a shape with one base and triangular lateral faces, well, they all have to come together at one specific point, which we're going to call the vertex. We could also call it the apex, but we'll go with vertex. The vertex there, that's how we define a pyramid. Now the other thing you'll have to do on the quiz and the homework, you'll have to actually name our different prisms. So I'll give you a shape. You have to give me the specific name. So how do we name these? Well, let's look at our first example here. So to name that prism, all I'm going to say is, well, what's the shape of my base here? My base is a triangle. Notice it's a prism because I have two congruent bases. The top and the bottom are both triangles. My lateral faces, the faces going around the side, those are all parallelograms. So to name this, I'm just going to go off the base. I'm going to say, what's the shape of my base? It's a triangle, so all I'm going to say is that this is a triangular prism. And that's my answer. Let's look at our next one. Well, this one here, what's the shape of my base? Well, I can orient this however I want, really. But there's a base. Those are my two bases, the top and the bottom there. So given those top and bottom bases, they are both rectangles. My lateral faces are parallelograms, so this would be a rectangular prism. So basically just look at the base. What's the shape of the base? And that's how you determine the name. Well, this shape here, what's the shape of my base? Well, notice that the shape of the base is, we have this guy right here. Those are my bases. My lateral faces are rectangles. And so to name this, so since the bases are pentagons, I'm going to say that this, I wish I had a little more room. So this is a pentagonal. Pentagonal. And this is a prism. But with this one here, and this one, notice that the lateral faces and the bases, they all form right angles. Even this one here, it's slanted a little bit. The entire shape is at an angle, but the actual face and the base forms a 90-degree angle. It's a right angle. So this would be a pentagonal right prism. I could add right to all these. I probably wouldn't dock you any points if you didn't add that. But since they are right prisms, you can say it's a triangular right prism. This is a rectangular right prism. This one here, it's a pentagonal right prism. So go ahead and try this one on your own. Pause the video. Should take you 2 seconds to write it out. So this would be, I look at my base. What's the shape of my bases? They're both hexagons. So I would name this. I'm also going to check, is it a right prism? It is. So this would be a hexagonal. Just a second. Hold up. I spelled that wrong. There you go. Hexagonal right prism. That's how I do that one. Now let's look at this one over here. Now this is not a right prism because I don't get a right angle right there. So this one, the way that I'd name this is I'll say that this is oblique or slanted. So this is oblique. I look at my bases, they're both triangles, so this would be an oblique triangular prism. That's how you do that. So on the homework, you guys will have to name these shapes. You will also, on the quiz, have to name the different prisms, name the edges. What are all the edges I have? Count them up, make sure you write them all out. And then you'll also have to name the faces, name the bases, and so on. So go and try, now we're looking at prisms. So see if you can do this on your own. It's the same principle, except we're going to be having pyramids instead of prisms. So when we're looking at this, again, it's all about the base here. So here, I'm going to erase. We're not going to worry about these right now. We'll come back to those later. So for this one here, that since the base is a triangle, I'm going to say that this is a triangular pyramid. It's that simple. Now let's look at this one. Now what's the shape of my base? The shape of my base is a square. And one other thing we gotta look out for, if I go from the vertex, if I draw a perpendicular line to the base, if it lands right in the middle there, and if it's perpendicular to the base, if I don't get anything that's not in the center, then I can say that this is a right pyramid. So the base is a square, so I'd say that this is a square right pyramid. Our next one here, again, if I construct that line, that perpendicular line from the vertex going to the base, it lands right in the middle, so I get a right pyramid. This is also a right pyramid. Now the shape of the base is a pentagon, so this would be a pentagonal right pyramid. Now this one here, again, if I were to construct that vertical line. That gives me, it's perpendicular to the base and it lands in the middle of the hexagon, which is our base here. The base is a hexagon. So this would be a hexagonal right pyramid. Now this last one here, that's oblique, it's slanted. So this would be in oblique, rectangular, because my base is a rectangle. Pyramid. Okay, a few more concepts and we'll be done. Video's getting a little bit long, but these shapes here are not polyhedrons because a polyhedron, you have to have polygons as the faces. And here, notice that I don't have polygons as the faces. So what are my different non-polyhedron three-dimensional shapes? Well, our first one here, we have a cylinder. And that's just made up of two bases that are circles. This one here, we have a cone. The cone, you have one base, and the base is connected to a single point called the vertex. And you guys have seen a cone before. Just think, like an ice cream cone. But the important thing for the cylinder and the cone is that the bases are circles. That's important. And our last one here, this is a sphere. Okay, a few other concepts. We're going to have these things called polyhedron nets. Now, what exactly is a net? A net is just you take a three-dimensional shape, and if you were to unfold it into a two-dimensional surface, so a flat surface, take your three-dimensional solid, make it two-dimensional, what would that two-dimensional shape look like? That's what we call a net. So if I take my cube here, if I were to unfold it, imagine slicing all these edges in a certain way to lay it flat on the ground, that would look like what? Well, that would match up with this right here. So if I take my three-dimensional, so this is all 3D, this is all 2D. If I go from 3D to 2D, I have to make it flat. This is what it would look like flat. What if I look at my square pyramid here, square right pyramid? If I take that, and if I were to cut all the edges here, cut all those edges, unfold it, what would it look like two-dimensionally? Looks like this one. So go ahead and pause the video, try and do the rest of those on your own. You got 6 of them, try and do those on your own if you can, and we'll correct together. So if I look at number 3, what would that look like if I were to cut it, unfold it? Well, number 3 would go with D. Those two match up. Let's look at number 4. Number 4 is my triangular pyramid, or if I were to cut that one, cut the edges here, unfold it, that goes with E. Let's look at number 5, my cylinder. If I were to picture cutting this edge here, cut around these sides here, and unfolding it. Well, if I were to do that, and keep this one attachment here, that looks like that. So conversely, if I were to take this shape here and fold it, it would give me that. Now let's look at our last one. So this one here, This is a triangular, even though it's on its side, the bases are triangles. These are the bases. So those are my triangular bases, and this would be a triangular this would just be a triangular prism, triangular right prism, because I get perpendicular lines here. So what would my triangular right prism look like? Well, if I match that up, that would come up to B. That would look like unfolded. So those are my polyhedron nets. Now, last thing, we're going to look at cross sections. A cross section is basically if I were to take a shape and take a flat surface, or a picture just taking a knife and slicing it at a certain point. So if I were to take this is a triangular pyramid. If I were to cut it with a flat surface here, what would be the shape I get from that slice? Well, the intersection of my two-dimensional flat surface here and the three-dimensional triangular pyramid, I would get a triangle. So the cross section is a triangle. This one here, if I were to take the cross section and I cut it right in the middle there, what kind of shape do I get? Well, this is a cylinder, the base is a cylinder. I cut it right there, I'd also get a circle for the cross section with that given cut. This here, I have a hexagon as my base. Here's a base, on the other side is a base. So if I were to cut it with my cross section, I would get another hexagon. So the cross section would be a hexagon. Now, this one here, if I were to, this is a cone, but notice I'm cutting down vertically down. What kind of shape would I get if I cut vertically down? When I look at this one, that would actually give me, look at the cross section, it gives me a triangle. So a triangle would be my cross section. Alright, sorry for a little bit longer video, a lot of little details that I had to go over, but make sure you guys either I'd suggest printing out the notes, or you could, I guess, just write on the picture that I send you. But make sure you guys do take notes, and have a good day. Email me if you have questions.